in radians. So what is a revolution in radians? 2 pi. So to find coterminal angles, I add or subtract coterminal or revolutions. I add or subtract revolutions. So if I took pi over 7 and added 2 pi, that would not be a negative number. And the problem stipulated a negative answer. So I'm going to take pi over 7 and subtract 2 pi. It's just a matter of getting a common denominator. So I have pi over 7 minus 14 pi over 7. So that would be negative 13 pi over 7. Coterminal angles start and stop in the same place. There's a revolution difference between them. So you either add or subtract a revolution. Okay, John? All right, who else has one that you can't figure out why you missed it? Your papers were all perfect. Reese?
Number 4.
Just tell me what the question is.
Secant 3 pi over 4.
All right, so we're finding the secant of 3 pi over 4. So a couple of things pop in my head. One is the secant is the reciprocal of the cosine. Cosine, so catoa is adjacent over hypotenuse. So I'm going to be looking for hypotenuse over adjacent. The other thing that pops into my head is 3 pi over 4 is a radian measure. And I might want to change that into degrees. So pi is 180, divided by 4 is 45, times 3 is 135. So I'm finding the secant of 135. Reese, are you with me up to this point?
Yeah.
All right.
Good.
Now, I'm going to draw 135. So here, I know this is 90 and I know this is 180. So here I am at 135. Drop that perpendicular straight down. How big is that angle right there? That's the key to the whole problem, that reference angle right there. How big is he? 45? Reese, got that?
Yeah.
45? So that's a 1, 1, root 2 triangle. Now, I'm not in quadrant 1, so something is negative. If you're not in quadrant 1, something is going to have to be marked negative. It's never the hypotenuse. In this case, what will be marked negative?
The x.
The x, the negative 1, the x. So now I'm ready to do hypotenuse over adjacent. Hypotenuse over adjacent would be negative root 2 over 1 or just negative root 2. All right, anybody else? Anything on the quiz? Tomas?
Find the angle whose cotangent is 3 over 4.
Okay, I love the fact he even read it right. The problem looks like this. And he said, find the angle whose cotangent is root 3 over 3. This question is different than this one. This one, we knew the angle and we were finding the fraction. Here, we know the fraction and we are finding the angle. Now, there are special rules associated with this notation, remember? Quadrants. But wait a minute. The rules were only given in terms of sine, cosine, and tangent, right? So I'm going to rethink this. There's an angle out there whose cotangent is this. So doesn't that mean his tangent would be this? Now that's awkward to us. We don't like that, so I'm just going to rewrite that. I'll rationalize it. What does that rationalize to? If I multiply top and bottom by root 3, doesn't that just work out to be root 3 over 1? So I have an angle whose tangent is root 3 over 1. Which quadrant will that angle be in? What are my choices with inverse tangent? 1 and 4. Positive number. So it's gotta be 1. And the tangent is opposite over adjacent. So there's my triangle. Does that make sense to everybody? So what's the angle? 60. So the answer to the problem is 60 degrees. All right, anybody else before we? Okay, what review sheet did we do? Each class has done one. Did we do the practice test?
Yeah.
We did a pre-test or practice test, which one? And did we finish it?
Yeah.
Okay, so we're ready to start on something else. So here's what we're gonna do. If any of you have started a worksheet and found a question, I want to take care of that right now. So have any of you started a question or started a worksheet, found a question you weren't able to answer? Anybody at all?
This one, right? Or is it the-
No.
Is it the big one?
No, yeah, okay. But, if nobody's got any questions that are burning right now, I have one more good review that I want us to look at. One day, this month, so now, recently, I handed out something called quick review. Remember we went through those quick reviews and we had a quiz over them? That was stapled to another paper. So if you can find your quick review paper, that we did in class, we did these quick reviews together, and then that's what our quiz was over, remember? It was stapled to another paper, which is an old quiz, but it is over the whole chapter. So this is gonna give us a good review, including some graphing. All right, so if you can't find it, that's fine, just write down these problems as we go. So the first one says the cosine of -3 pi over 4. This is very much like the quiz question somebody asked me about. We're on the cosine. We know the angle. In fact, that might be the exact same angle we used before. -130, well, it's negative now, so it's -135. Everybody good with that?
Yeah.
Now, what do we do when we have a negative angle?
You go the opposite.
We go the opposite way. So instead of going around this way to 135, I'm gonna go this way to 135.
Yeah.
So this is -135 right here. So this is -135, and this would be -180. Go in this direction. So how big is that reference angle again? 45. So I'm a 1/1√2. Anything negative? Both of the ones. Now, if we've done some of these before, so I'm kind of rolling through. If you got a question, you need to stop and ask me, okay? Otherwise, I'm just gonna keep rolling. All right, what's the cosine? Cosine is adjacent over hypotenuse, so that's gonna be -1/√2 or -√2/2. Right? Tangent pi. Now this one's a little bit different because what's pi? 180. And what happens when we draw 180? Yeah, we do not get, 180 is right here. We do not get this line, this angle sticking out in the quadrant. If we get the angle sticking out in the quadrant, we can make part of our butterfly bow tie. We can make a triangle. If the angle's not sticking out in a quadrant, what do? We think of it in terms of the circular functions. This would be, so instead of thinking about SOHCAHTOA, we think about y over x. Tangent is y over x. So at this point right here, this is 180. I arbitrarily make my radius 1 because it just makes life simpler. You can make the radius whatever you want, it won't change your answer ever. Make the radius 1, so that's the point, -1, 0. That's your x, and that's your y. So what happens when you put y over x? You get 0 over -1, which is 0. Remember, 0 on top is 0. 0 on the bottom is undefined. All right, next equation. Is this thing sinusoidal? What is its period? Okay, well, what do you think? Is it going to be sinusoidal?
No.
No, you can tell by looking, because in order to be sinusoidal, the period of each piece has to match. But when you find the period of this, you're going to take 2 pi and divide it by a half, right? When you do this one, you're going to take 2 pi and divide it by a third. Since those two numbers are different, 1/2 and 1/3, obviously the periods are going to be different numbers, right? So you can just tell by looking at this, no, it's not sinusoidal. What is the period of it though? Well, the period of this piece, if we simplify that, will be 4 pi. And this piece will be 6 pi. So the period of the whole thing is the first number in their list of multiples that's the same. So 4 pi, 8 pi, 12 pi, 16 pi, and so on. And 6 pi, 12 pi, 18 pi, and so on. This time we have a period of 12 pi. Everybody remember that? Number 4. What is this asking me for? An angle. When you see that notation, you know the answer is an angle. So first thing you got to do is figure out, where is this angle going to be? There's only one answer. You're not looking all the way around the circle. You're looking at a very particular place. Where are we looking? Quadrant 4. You got to know the rules, people. Inverse sine is 1 and 4. So is tangent. Inverse sine and tangent are 1 and 4. Cosine is 1 and 2. So this one would be in quadrant 4. Why? Because the number's negative. And if you're in quadrant 1, you don't have any negatives. So it must be down here. The sine is opposite over hypotenuse. So the other side would be √3, and how big is that angle right there? You should be able to tell. That is a negative 30-degree angle. The answer is negative 30. What happens if you say positive 30? Well, you miss it, because that's in quadrant 1. Positive 30 is in quadrant 1. It's got to be negative 30.
How come that one's negative 30, but this one's just regular 45?
This angle?
Yeah.
Well, that wasn't the answer to the question. So that, it doesn't matter. What I needed here was the sides of the triangle. So whether that's positive or negative isn't going to change that. That was a different question. Here, the answer is the actual angle, so I have to make sure I have it signed correctly. All right, the next one says, find the tangent of the angle whose cosine is 5/6. So I start by what? Drawing the picture. Where am I going to draw it?
And 2.
It's either 1 or 2. That's a positive number, so I'm going to draw it in 1. Alec, you okay with that? Quadrant 1? Okay. Now I've labeled adjacent over hypotenuse 5/6, so now I will do what? Pythagorean theorem. that would be, let's not miss this. That would be 36 minus 25. So the square root of 11. Now, I have no idea what the measure of that angle is. It's not like that one over there. I have no idea. But I don't care because I'm looking for the tangent. And whatever that angle is, the tangent will be opposite over adjacent. So the answer is root 11 over 5. All right, now we're finding the radius. Of that thing. Now when you look at that, hopefully what pops into your head is arc length equals radius times radians. And we know our arc length is 4. We don't know the radius, but we actually this time have the radian measure. Usually I try to mess you up by giving you the angle in degrees. So the first thing you have to do is change it. But I've given it to you in radians. So now what happens? We're going to multiply by 7 over pi. Technically we're dividing by pi over 7, but that's the same as multiplying by 7 over pi. So the answer, those will cancel, and the answer to the question is 28 over pi. This was in centimeters, so the radius is going to be in centimeters. What is the period of this cotangent equation? We gotta be careful because every time we've done a question that's involved period, usually we do 2 pi divided by that coefficient, but the tangent and cotangent are different. Remember, they have a different shape. What is the normal period of the tangent and cotangent? 1 pi. 1 pi. They go from asymptote to asymptote, and they're pi apart. So the normal period of this is pi, so the new period is going to be pi divided by 1/3, which is 3 pi. To find the period, you always, whatever the function is, you take the normal period and divide it by that coefficient. For sine and cosine, the normal period is 2 pi. For tangent and cotangent, the normal period is pi. All right, now we're going to graph 1. All right, so here we go. Let's run down through, list everything. There is the list, first of all. Is that x minus pi over 8? All right, so amplitude, period, phase shift, vertical shift, and frequency. All right, here we go. Any of them. Amplitude's 3. And what that means is, when I sketch this, I'm going to go up 3 and down 3. Okay, that's right here. That guy right there. What else? Period is 10 pi because it's 2 pi divided by 1/5. And again, some of you are thinking, oh my gosh, Mrs. Ford, over here you did pi divided by that number. Because this was a cotangent. For cosine and sine, we use 2 pi. For tan and cotan, we use 1 pi. All right, and what that means now, kids, is when I draw my sine curve, the distance from beginning to end, from this point to this point, is going to be 10 pi. That's what that means when you say the period is 10 pi. All right, what else do I know? Phase shift is positive pi over 8, which means I'm moving to the right pi over 8. So this is going to be pi over 8. So the curve, instead of starting where it's supposed to, is now going to start over here. Vertical shift is 0 because there is no thing added or subtracted here. And our frequency is 1 over 10 pi. All right. So I've got the beginning of the graph there. Is everybody okay with that? So the only thing left to do, you're basically done except for your labels. You need to get your labels in there. So we remember that labels, we've got the beginning and end point, of course the middle point, and then the top of the hill and the bottom of the valley. So here we go. Anybody figure out what that end point is? The ending point? What is it? It wouldn't be 9 pi over 8. How far is it from here to here? What did we say that distance was going to be? 10 pi. So to get, which, by the way, is 88. So that's going to be 81/8. Morgan, I think you added pi. Yeah, we need to add 10 pi. So how did we get that end point? We took the beginning point and added on the period. Okay, what else? How about the middle? Can we get the middle point? How did you get 41 pi? You are exactly right. How did you do that? What was your thought process? Averaged them. What's the middle value? What's the average? 1 and 81 is 82, and half of 82 is 41. Now we'll do the same thing here. 1 and 41 is 42, and half of 42 is 21. I'm kind of seeing a pattern here. Is that 61? If this had been a cosine problem, you would do everything exactly the same, except you would have started and stopped here, so the picture would have looked like this if it would have been a cosine problem. Absolutely nothing else would be different, including all that. Anybody have an issue with that? All right, we're almost done with this. Paper number 9. We know that the tangent is 3/4, and this. And it says find the sine. Now I know what this means. This means I'm going to draw a triangle that has an opposite and adjacent that's 3 and 4. What does this do for me? What's that doing? That's telling me where to draw my triangle. What's this? Pi is 180, and this is, yeah, don't be confused by that. Pi is 180 divided by 2 is 90 times 3 is 270. Now what does that mean? If I'm between 180 and 270, what does that mean? I'm in quadrant 3. So this is just a fancy way of saying quadrant 3. I'm going to draw my picture in quadrant 3. And the tangent is 3/4. Be very careful about that. that 3 and that 4 are actually both negative. And I can do the Pythagorean theorem. 5. 5 is always positive. The hypotenuse, remember, is always positive. We want the sign, so that's pretty easy now. The sign is negative 3 over 5. Yep, good. Negative 3/5. Write the equation. A bird is sitting on top of a flagpole and notices a beetle on the ground. Alright? So we got the bird on the flagpole. There's the bird on the flagpole looking at the beetle on the ground. There it is. The bird's angle of depression is 27 degrees. Where do I put the 27? If you put it here, I am going to put a huge red X on your paper and write, because we never put angles of depression here. Angles of depression go here or here. Now when you put it here, technically it's an angle of elevation, but they always match. So it's 27 degrees, I'm going to put it right there. The beetle is 100 meters from the bird. The beetle is 100 meters from the bird. Where does the 100 go? Hypotenuse. The beetle and the bird. Find the height of the pole. Does anybody have a question about why a number is where it's at? Everybody can do that? Alright, now pick a function, sine, cosine, tangent. What's this one gonna do? Sine. We'll say sine 27. You always take sine of the angle. So sine 27 equals x over 100. So x equals 100 sine 27. That would be the equation that you use. If this is on the calculator part of the test, you'll type that in. Of course, that is a degree measure, so when you type that in, you're going to want to make sure you are in degrees. And finally, number 11, evaluate the secant of 11 pi over 6. Well, we already did one like this, but let's do another one. The secant of just pi over 6. Okay, pi over 6 is 30, that's easy. So I will draw 30. Here's 0, here's 90. 30 is coming out like this. Is that okay with everybody? So this angle is 30. So my sides are 1, 2, root 3. Secant is reciprocal of cosine, so I need hypotenuse over adjacent, which would be 2 over root 3, or 2 root 3 over 3. Now, having gone through that, which is about everything on the in the chapter, does that make you think of something you want to review now? We have a little bit more time. What do we still need to talk about? What do we need to review more? What do we need to do more of? John?
What was the measure for
Negative 30.
You do number 1 right here. It says write a sign.
Okay, so Alex wants to do one of these problems where I give you the picture and you write the equation. So let me Let me see if I can get one made up here pretty quickly. Okay, here we go. Let's see if I can do this. Look at that. Put some labels on here. Let's make this negative pi over 6. Okay, so this is not on a sheet. I'm just making this one up right now. And your job is to write a sine equation and a cosine equation for this picture. Okay, everybody get what we're doing here? I'm going to write a sine and a cosine equation for this picture. Now, the first thing you might notice is this thing appears to have been lifted up. Would you agree with that? How much has it been lifted up? 1. So you might, sometimes it helps me to go ahead and put in that axis so that I can see where things are rotating or, going up and down. The fact that I moved it up 1 tells me 2, this is going to be a plus 1 on the end. Would you agree with that? Now, can you tell from the picture what might go out here in front? A 2? Because the height of the waves is 2. So that's the amplitude. Good. All right, now we gotta just focus on one or the other. So when you see that, do you see a sine or a cosine first? You see a sine? Okay. If you see a sine, then you're probably looking at this part of the curve. Alrighty. So if that's the sine you're looking at, this would be plus pi over 6. Because if you're looking at that as a sine curve, you've shifted it to the left, pi over 6. And I don't know what this number is, but I do know that the period of a sine is always 2 pi divided by that number. Right? So when that was a 1/3, I did 2 pi divided by 1/3, right? What is the period? How far is it from this dot to this dot? From negative pi over 6 to 3 pi over 6 is 4 pi over 6, which reduces, I'll just leave it 4 pi over 6 equals 2 pi divided by n. So 4 pi n equals 12 pi, and it looks like n equals 3. So this number right here is a 3. It's going to be a 3 here. That hasn't changed. The only thing that's changed is, when I go to the cosine version, is what part of the picture I look at. Well, if it's a cosine, I got to start looking at the top of the hill. So that would be what I would be looking at as a cosine. Would you agree? Has it been shifted at all? No. Not sideways, I mean. So that would be a 0. All right, Alex, did that help? Was there part of that you were a little confused about or wondering about?
No.
Sure.
Where did you get the 2?
John, this number is the amplitude, which is the height of the waves. So how far up and down are they going? Okay. this whole picture has been lifted up 1 unit, because instead of rotating across the x-axis, which is how it's supposed to go, it's rotating across that line right there. Everything's up 1 point higher than it's supposed to be. All right, what else can we work on? I'm not letting you go early, so if that's your strategy, it's not working. All right, I'll make one up.
Wait. Finding the angle with like a sign.
Oh, you mean in a word problem like this? Or you mean in a problem like this?
Problem like that.
Alright, now if I'm not going to allow you to have a calculator, then I have to be very careful about what I put here. So let's do 2 of these. Let's do this one. And let's do this one. Now, for both of these problems, they're both signs. For both of them, we must look only in which quadrants? 1 and 4. So I will be looking here for my answer. Right? Now, that number you have seen quite a few times. This is the rationalized form of what? When you're doing your work, you never get that answer in the first step. You always make it the answer. What is the first step? -1 over root 2. And I say that because if you can think a little backwards like that, it's going to help you when you label the sides of your triangle. You're not going to recognize the root 2 and the 2, but you will recognize a 1 and a root 2 like that, right? This angle is how big? That's a 1, that's a 1, that's a root 2, so this angle is 45. But because it's in quadrant 4, it's actually -45. Is that okay? Now, let's suppose you didn't do this. Let's suppose you just did literally what it says. You made this -root 2 and this 2. You do not recognize those. Those are not numbers that we memorized. However, if you did the Pythagorean theorem, which would be the next logical step, if you did the Pythagorean theorem, 4 minus 2, this would come out to be root 2. And then I would absolutely expect you to recognize if you have a right triangle and 2 sides are the same, then that means these angles have to be the same, which means that has to be a 45. So it's a little more complicated that way, but you can still get the 45. All right, now this one is a wild card. This is different because that's a 0. You're not going to be able to draw a triangle where that's 0, right? So you have to look for a quadrantal angle. Now the only options are up here, out here, and down here. Why are those the only options? Because those are the only quadrantal angles that are involved on that half of the circle. So one of those angles, either 90, 0, or -90, one of those angles has a sign of 0 over 1, or 0. Which of those angles, if you put y over r, because that's what sine is on the unit circle, or on a circle, it's y over r. Which of those angles has a sine value of 0 over 1? 0, right here. So the answer to the question is 0 because. Alright. Alright, we have one more day of review. That's tomorrow. That's this Friday. I would anticipate that you will go home and spend some time on those review sheets that we haven't done. They are all videoed and posted, so if you get stuck, you can get on there and look. But also, if there's anything we need to practice, tomorrow would be the day to ask those questions. Okay?
This is
Yeah.
next flex or is it period?
I have no idea.